All right, so still finding exact answers. So if we are between 180 and 270, that is going to be quadrant 3. So again, I'm going to start with the triangle method. And since I'm in quadrant 3, draw my right triangle in there. All right, so we are given sine. So sine is opposite over hypotenuse. So opposite is -2 and hypotenuse is 7. All right, so again, I'm going to start by finding that missing side. So 2 squared is 4, plus our missing side squared equals 7 squared, 49. So I'm going to subtract the 4 over. So b squared would equal 45. Take the square root of both sides. So again, that 45 I'm splitting as 9 times 5. So make sure that we are simplifying as much as possible. So then this will be 3 square root of 5 for the missing side. And because we went to the left, I need to make that negative. So -3 square root of 5. Okay. And the question is asking for secant theta. So secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So that means that I need to do the hypotenuse, which is 7, over the adjacent side. So -3 square root of 5. So I need to rationalize this. So I'm going to multiply by the square root of 5 to the top and bottom. And then as I do that, the negative is going to be simplified to the top. So this will be -7 square root of 5. And then the square root of 5 times square root of 5 is 5. So on the denominator, it should be a +3. I'm really doing 3 times 5. So that's going to give me 15. So secant theta is going to equal -7 square root of 5 over 15 for that final answer. All right, so if we do the other method, so the Pythagorean Identity one, we want to start by looking at which trig function they gave us. So they gave us sine. So on my identity, I'm finding the one with sine in it. So we're going to use this top one. So using cosine squared theta plus sine squared theta equals 1. And then we substitute in what we know and solve for what we have left. So if I square that fraction, we will have cosine squared theta plus 4 over 49 equals 1. Okay. Right, so I'm going to subtract that. Again, you can type that right into your calculator. Or if we have 1 here, this is really 49 over 49. So 49 minus 4 is going to be 45. And then over 49. Okay. And then we're just taking the square root of both sides. So this will be cosine theta equals, and then let's see, if I split this, it's going to be the square root of, so again, 9 times 5, so 3 plus minus 3 square root of 5 over 7. Okay. All right, so notice how we ended up with cosine, but our question is asking for secant. So what that means is I need to flip this over to the reciprocal to find secant. So secant theta equals, and then plus minus 7 over 3 square root of 5. So I need to rationalize, so I'm just multiplying by square root of 5 to the top and bottom. And remember when I do this, that's really 5, so I have to multiply those two things together. So I have plus minus 7 square root of 5 over 15. And then now I have to decide which sign I need, so the positive or the negative. Okay, so all students take class. And according to my given information, we are in quadrant 3. So that means tangent is positive, all other answers are negative. So that means I'm going to keep the negative of this answer. So secant theta equals negative 7 square root of 5 over 15. And that is going to be my final answer. All right, last example for this kind of problem, and then we're going to move on to simplifying. All right, so the question is asking us to find tangent theta if cotangent theta equals 4 and our theta is between 0 and 90. So that means that we are in quadrant 1. And if I'm thinking about this, so all students take class, that means that my answer has to be positive no matter what. And I don't want to make this any more difficult than I have to. So I don't actually need either of these methods to solve, although we could do that if we wanted to. I just have to know that cotangent is the reciprocal to tangent. So I'm going to think of 4 over 1, and then I just flip it to get the tangent answer. So tangent theta equals 1 over 4. And that is my final answer for this problem. Okay, so don't make things more difficult than they need to be.